Hello and welcome. Failure mode and effects analysis, or FMEA, is a method for evaluating potential technical risks of failures for products or processes. It's a team-oriented, systematic, qualitative way to analyze the causes and effects of those failures, document preventive and detection controls, and take action to reduce risk. The AIAG VDA FMEA standard is widely used to enhance product quality and reliability in the automotive sector. The AIAG and VDA organizations has published and revised a FMEA handbook aimed at harmonizing approaches across the automotive industry. This resulted in a significant update to the FMEA process. This handbook specifies a set of guidelines for using the FMEA in the automotive industry to systematically evaluate and manage potential risks in product design and manufacturing processes. Let's review 8 main differences between the AIAG VDA approach and the earlier versions of FMEA. The first major change is the structure and steps of FMEA. The FMEA handbook introduced a 7-step process to align more closely with VDA, or the German Automotive Industry Association standards, focusing on a structured approach to risk analysis. These 7 steps are grouped into 3 phases of system analysis, failure analysis risk mitigation, and risk communication. The second major change is the additional guidance on assigning severity, occurrence, and detection ratings. Earlier FMEA versions also use these ratings, but often without much structured guidance or criteria, leading to potential variability in ratings between individuals and organizations. The AIAG and VDA FMEA approach emphasizes the use of criteria tables as a basis for standardized assessment of severity, occurrence, and detection ratings across different users and organizations. The third difference is in the shift in emphasis on how we prioritize risks and actions to mitigate risks. Recognizing the limitations and ambiguities of RPN, or risk priority numbers, the AIAG and VDA FMEA approach de-emphasizes this in place of a metric called action priority. The action priority tables provide a new way to prioritize actions, placing greater emphasis on severity of the risk. Fourth, the AIAG and VDA FMEA approach encourages a stronger focus on preventative measures rather than detection controls. This aligns with a more proactive approach to risk management espoused by FMEA. The fifth change is that the AIAG and VDA approach provides additional structure to analyze systems, subsystems, and the interactions between them. In contrast, earlier versions of FMEA often focused more on component-level analysis without as much guidance on system interactions. Sixth, the AIAG handbook introduces new worksheets that require more detailed documentation. The aim is both to ensure consistency and thoroughness in the FMEA process and to capture details during each step that simpler formats could miss. The 7th change was to modify and harmonize terminology and concepts between the AIAG and the VDA approaches to FMEA. This is especially important for establishing a common understanding and application across global organizations and supply chains. The 8th difference is an emphasis on collaboration through a standard approach between suppliers and manufacturers. FMEA was often used within individual organizations who may have used different approaches to identifying and addressing risks. These changes were made with the intent to improve the robustness and consistency of FMEAs within the context of the global automotive industry as an effective means of risk management. That wraps up our review of the AIAG standard for FMEA. We'll see you soon.